Okay, so the first portion of the notes, we're going to use factoring to solve for our zeros, and we're going to combine that with our knowledge of in behavior to graph a prediction of what this function should look like. So this is not going to be accurate as far as specific points, so this is why we don't need the graphing calculator for this section. Okay, so just remember that if you have a factor, say x minus k of a function, and it's raised to an odd power, the graph is going to cross at that x equals k root. So if I gave you a function like f of x equals something like x plus 2 times x minus 3 squared, okay? Say this is the function once it was factored, all right? So you know that you could set it equal to 0, solve it, and that's how you solve for your roots. Well, you would end up getting x equals negative 2, and you would end up getting x equals 3. But what's special about the x equals 3? It should be a double solution. Well, we know that because the exponent is raised to the power of 2. So what these two bullet points are telling you is that when you just have something to an odd power, it's going to cross at that x-intercept, whereas if it's an even power, like a double solution, that's where it's just going to touch it and bounce back off. Okay, do y'all remember that a little bit? So it's just going to touch, it will bounce back off. That's important to know whenever we're predicting what our graphs look like. Okay, so remember that if you have an odd degree, they're going to go in opposite directions. Okay, if you have an even degree, what I mean by they're going to go in opposite directions, or your in behaviors are going in opposite directions. Even degrees, they'll go in the same direction. And remember that your leading coefficient sign determines the right in behavior. So if it's positive, the right side is going to go in the positive direction. If it's negative, then the right side is going negative. It always determines the right. Okay? So use factoring to find the zeros of the function, then sketch the graph using what you know about single or multiple zeros in behavior. So we've got f of x equals 2x cubed minus 12x squared plus 18x. We're going to set that equal to 0 so that we can solve, because remember that you cannot solve an equation if it's not equal to 0. At that point, you're just factoring an expression, not factoring an equation. So I need to look, my first thing is take out a GCF, or try to at least, okay? My GCF here would be 2x, and that would leave me with x squared minus 6x plus 9 equals 0. Alright, then I need to factor what's inside parentheses. Do you recognize anything about that trinomial? It's a perfect square trinomial. Okay, if you didn't recognize that, that's okay. You can still go through the thought process. Factors of 9, that would give me a 6, would be 3 and 3. So if you catch it, and you know that it's going to be x minus 3 squared equals 0, that's fine. Or you can do 2x times x minus 3 times x minus 3 equals 0. Okay, either way, I will be fine with either way. Okay, now say you recognize it and you set it up like this. Well, either way, you're going to have to separate and solve. So 2x is equal to 0, x minus 3 is equal to 0. So x will equal 0 and x will equal 3. Now what do I need behind that 3? My double solution. Okay, so I need to think about what's going to happen at these two roots. So x equals 0, is that going to cross or bounce off? It's going to cross, but the x equals 3 is going to bounce. Okay, so I'm going to plot my 0, I'm going to plot my 3. And I got to think about my in behavior, right? So what type of degree do I have, odd or even? I have an odd degree, so they're going in opposite directions. My leading coefficient is positive, so that means it should end positive, so it starts negative, right? So, like I said, it's a not going to be as accurate. So I might have go up a little bit and then come back down. You might go up a lot and come back down. Just make sure it's a neat graph, okay? You're not going to have your graphing calculator on this section of the test, so there's no way to know just how far or low it dips or goes up. So all I'm looking at are your intercepts, how they cross or bounce, and your end behaviors, okay? So I'm going to start negative, cross through that, go up, and I'm going to come down, touch the x equals 3, and come back up. Y'all good with that? Any questions? Okay. So then we're going to do the same thing. I've got negative 2x to the fourth plus 16x squared minus 32. So I'm going to set that equal to 0. Do I have a GCF here?
Yes, you or negative 2, depending on how it
So if it starts with a leading negative, I'm still going to take that out as a GCF. So it would be a negative 2. And that would leave me with x to the fourth plus 8, not plus, that would be a minus. Yep, minus 8x squared plus 16. Okay, so I bring down my negative 2 because I have to have that. Now you might have recognized it, you might not. That's another perfect square trinomial. But I'm not setting it up like that because this x to the fourth will split into x squared and x squared. And then I'm going to have x squared minus 4, x squared minus 4. I didn't set that squared because I know what happens here. If you recognized it and you set it as squared, that's fine. But this is the difference of two squares. Okay? So this is going to split further. X plus 2 times x minus 2, and then it does it again, x plus 2 times x minus 2 equal to 0. So if you did negative 2 x squared minus 4 squared equals 0, what's going to happen is you need to show me that that's x plus 2 squared and that's x minus 2 squared equals 0. I think y'all are better off doing it this way, but it's up to you. I'll accept either because what happens is you've got x plus 2 equals 0, x minus 2 equals 0, and they're both going to be double solutions because they show up twice. Y'all follow me?
Yes.
Okay. So I'm going to have x equals negative 2 double solution and x equals 2 double solution.
Both bounce.
Yep, they both bounce, so I'm going to have a negative 2 and 2 plotted. Now you think about, I have an even degree, so they're going to go in the same direction. What direction are they going?
They both go down.
They're going down because it's negative. So I'm going to start down, come up to the negative 2, bounce off, go back to the positive 2, bounce off again. Make sure you have your arrows. And that's it. Y'all good with that? Okay. So example 3, without graphing, find all the zeros of the function. So this is where you just get it equal to 0 and factor and solve. Okay? So if I have 2x to the fifth plus 24x equals 14x to the third, what do I need to do there to get it equal to 0? Subtract your 14x third. Yep. So I'm going to have 2x to the fifth minus 14x cubed plus 24x equals 0. So I'm going to take out a GCF again, and that's going to be 2x. And that leaves me with x to the fourth minus 7x squared plus 12. So when I factor that, I have 2x. Factors of 12, that will give me a negative 7. Negative 3, negative 4. So I have x squared minus 3, and I have x squared minus 4 equals 0.
Any difference in 2 squares?
So, yes, one of those isn't going to be the difference of 2 squares. I'm going to bring that up to the top because I'm running out of room. So I have 2x. I'm going to leave x squared minus 3 because I can't do anything with that. But x squared minus 4 splits x plus 2 times x minus 2 equals 0. So make sure you go as far as you can, factor it completely before you start separating and solving. Okay? So here I'm going to have 2x equals 0, x squared minus 3 equals 0, x plus 2 equals 0, and x minus 2 equals 0. So for my 2x equals 0, divide by 2, x equals 0. For that x squared minus 3 equals 0, since I could not factor that, I'm going to solve using square roots. Okay? So I'm going to add that 3. X squared will equal 3. And then I'm going to take the square root of both sides. Remember what you need to do with the square root. The very next step after you do the square root, you better have your plus or minus there. So x equals plus or minus square root of 3. For x plus 2 equals 0, subtract your 2, x equals negative 2. X minus 2 equals 0, add your 2, x equals 2. So really, I have 5 solutions, right? Because this counts as 2. So I've got 1, 2, 3, 4, 5. Look at your degree of that exponent. That tells you how many solutions you're going to have. Okay? So that's just a heads up of what's to come in a minute. Now, this next section that we're doing is we're spiraling this back in. We've already done this, okay? The ones like 4 and 5 on y'all's last test, y'all did not have trouble with. But if you look, when we start getting to the conjugates, 6 and 7, that's where y'all started messing up on y'all's previous tests. So I threw this back in here so we could get more practice with it, okay? It is chapter 5 still, so it fits within our section. Remember that with imaginary solutions and radicals, you can use the conjugate, okay? So if a plus bi is the solution, then you have to understand that the conjugate, a minus bi, is also a solution, okay? That's how you're going to get your imaginaries to cancel. But when we have just basic real numbers, no imaginary, then you just do whatever I give you, okay? So if I give you these zeros, I'm giving you x equals 4, x equals negative 1/3, and x equals negative 2. And we have to write that function, okay? So remember that you are getting from the 0 format to, you want to go to a factored format. So we're going to have f of x all the way through. Now remember, on some of y'all's, you weren't doing f of x all the way through. You would only do it at the end or only do it at the beginning. And make sure you're doing it all the way through. So if I have x equals 4 in 0 format, in factored form, that should be x what? Minus 4. You change the sign. Now, I'm not going to have x plus 1/3, right? I'm not going to accept fractions like that. So you've got to think about it. Yes, you're going to move that 3 with the x, so it's going to be 3x, change the sign, plus 1. And then x equals negative 2 becomes x plus 2. Okay? Then we FOIL it. Now, I always do the last 2 before I do that front one. As long as your work is there, I don't care what order you do. So 3x times x will give me 3x squared. 3x times 2 would give me 6x, plus 1x would give me 7x. And then 1 times 2 would give me 2. Okay, question. Then you're going to distribute that x minus 4 through. So when I distribute that x, I get 3x cubed plus 7x squared plus 2x. Then I'm going to distribute the negative 4 through. I get negative 12x squared minus 28x minus 8. Then we're going to combine like terms. F of x equals 3x cubed. 7x squared minus 12x squared is going to give me a negative 5x squared. 2x minus 28x is going to give me a negative 26x minus 8. Y'all good with that? Y'all remember doing this? Okay. Make sure y'all are boxing y'all's answers. When y'all get to the AP test for calculus, if you don't box in an answer, you don't get points. So make sure y'all are getting in the habit of boxing in your answers. Okay?
Oh, wait. What if it's the only thing you write for the question? Like, you do it in one step. Do you still have to box it in?
When you get to calculus, you're not going to have a problem where you do it in one step.
Okay, fair enough.
So here's where we throw in imaginary, okay? So if I give you negative 5i, what is also understood to be the solution? Positive 5i, okay? So I've got x equals 2, x equals negative 5i, x equals positive 5i. Now this x equals 0, when you have that, when you start writing your factored form for your function, that x equals 0 is just an x. And I put that at the very beginning. Okay, then I'm going to have x minus 2. Now when I change the sign for the negative 5i, that becomes x plus 5i. And then the positive 5i turns into x minus 5i. I don't really care what order you have that in, as long as you have it all there, okay? So I can multiply x times x minus 2 in the same step that I FOIL my imaginary binomials. So I should have x squared minus 2x in the first set of parentheses. Then I've got x squared. I'm going to have a negative 5ix and a positive 5ix. That's going to cancel, right? And then I'm going to have a negative 25i squared. What happens with that negative 25i squared? Turns to a positive 25. Okay? Now, if you need to rewrite it for neatness, you can, but when I'm going to know that's a plus 25 whenever I distribute. Bless you. So, x squared times x squared gives me x to the 4th plus 25x squared minus 2x cubed minus 50x. Can I leave that as my answer?
Oh, no.
Why?
You have to switch your 25x squared and make it 2x cubed.
Yeah, I have to make sure it's in standard form. So, x to the 4th minus 2x cubed plus 25x squared minus 50x.
I just skipped to the last x squared minus 2x cubed without doing this stuff.
Without doing this?
Yeah.
If you can do that in your head and you can keep up with it, that's fine. As long as I can read what you're doing, I mean, I'm good. Y'all good? Okay. Now, 6 and 7 is where it looks more complicated when you put it all together, and I think that's where all the errors were going. So yesterday when I taught it, I lined up my like terms instead of writing it all horizontally. So I'm going to try that with y'all, see if you like that better. If you don't, just write it all out horizontally. It's fine. So here I'm going to have x equals 3, x equals 2 plus square root of 5, and what else am I going to have? X equals 2 minus square root of 5. You're still going to have that conjugate there. Okay? So when I start my function, I'm going to have x minus 3. Now, I'm going to have x minus the entire 2 plus square root of 5. So you have to keep up with your parentheses here. Okay?
Wait, what if you like, couldn't you just, instead of all the parentheses, within the parentheses, just do x minus 2 minus square root of 5?
Yes, I was about to get to that. So I'm going to write it all out. No, it's okay. I'm going to write it all out and then tell you if you can do it in your head and keep up with it, that's fine. The problem is on y'all's last test, some of y'all were changing the sign of the 2's and having a minus 2 and a plus 2 instead of having a minus square root of 5 and a positive square root of 5. Okay, so you're going to have to keep up with knowing what signs are actually changing there. Okay, so if you can go straight to x minus 3 times x minus 2 minus square root of 5 and x minus 2 plus square root of 5, I'm totally fine with that. Just know it's the radical that's the plus and minus, not the 2 itself. That's where the most common mistake I was finding in y'all's last test. Then we're going to, this is a whole lot to distribute. So the last time I taught it, we did it all in one row, and it was really long. Okay? If you like that, that's fine. You just have to really keep up with your like terms, which again is where mistakes were being made heavily on y'all's last test. So if we're going to line up like terms, I tried to keep it all in columns. So I have x times x, which is my x squared. X times negative 2 is my negative 2x. Then I've got x times square root of 5. Okay? So I've got a plus square root 5x. Then I'm going to have a negative 2 times x. So I'm going to put that right underneath that negative 2x. This is where I just start my own columns of like terms. Okay? Negative 2 times negative 2 is a positive 4. That's going to be back over here because I don't have a like term for it yet. Then negative 2 times square root of 5. Now, that's not going to be the same as square root of 5x, is it?
No.
No. So I'm still going to have negative 2 square root of 5 over here. I'm just trying to have like terms in the same column here. So then I've got a negative square root of 5x. That lines up. I now have a positive 2 square root of 5. That lines up. Negative square root of 5 times positive square root of 5 is just a negative 5. Okay? Again, you don't have to do it this way. You can do it all in order, all horizontally. But this makes it easier visually if you are more visual. Okay? So then I can see I have x squared. Negative 2x gives me negative 4x. Square root of 5x minus square root of 5x cancels. Negative 2 square root of 5, positive 2 square root of 5 cancels. And I have a negative 1. And then I'm going to multiply through that x minus 3. So x cubed minus 4x squared minus x minus 3x squared plus 12x plus 3. So my final answer, f of x equals x to the third. Negative 4x squared minus 3x squared gives me negative 7x squared. Negative x plus 12x gives me 11x plus 3. You're good with that? Okay. Would you rather me write it all horizontally for this next example, or are you okay with this? Does it matter? You don't care? Okay. So the same concept, except this is an imaginary instead of a radical. So I've got 3 plus 2i. So then what else am I going to have?
Minus 2i.
3 minus 2i. And then x equals negative 3. So when I start my function, I'm going to have x plus 3. So here is where, if you knew it's going to be x minus the entire 3 plus 2i, that really is just what? X minus 3 minus 2i. Right? And then you're going to have x minus 3 plus 2i when you subtract the 3 minus 2i. So absolutely you can do that in one step. Then we're going to multiply. X times x is going to give me my x squared. Then I'm going to have a negative 3x. And I'm going to have a positive 2ix. Then I'm going to have another negative 3x. And I'm going to have a positive 9. And then I'm going to have a negative 6i. Then I'm going to have a negative 2ix, a positive 6i. Okay, negative 2i times positive 2i is a negative 4i squared, which is just plus 4. So x plus 3 times, I'm going to have x squared minus 6x. My 2ix's cancel, my 6i's cancel, and I just have 13 left. Are good with that? Then continue to distribute x plus 3, so I get x cubed minus 6x squared plus 13x plus 3x squared minus 18x plus 39. So I'm going to have x cubed, negative 6x squared plus 3x squared gives me a negative 3x squared. 13x minus 18x gives me a negative 5x plus 39. You're good? Any questions? Okay. The fundamental theorem of algebra tells you that if you've got the function f of x, and that's a polynomial degree of n, where n is greater than 0, then the equation f of x equals 0 has at least one solution in the set of complex numbers. Okay. Corollary to that tells you that if you have that function, and that's a polynomial degree of n, where n is greater than 0, then the equation f of x equals 0 has exactly n solutions. So how earlier I pointed out your degree was 5 and you had 5 solutions, that's really what this is talking about. Okay? So your degree is telling you how many total solutions you have, okay? So if I have 2x minus 1, that's linear, that's first degree, I only have one solution. Okay, if I have x squared minus 2, that's quadratic, a degree of 2, I have two solutions, a plus and a minus square root of 2. If I have a cubic, I have 3 solutions. Even this right here, still considered a degree of 3, so I still have 3 solutions, okay? So if I'm looking at f of x equals 4x squared minus 5x to the 4th plus 3x minus 2, could you look at that and tell me how many solutions I'm supposed to have? How many? 4. I don't even need that in standard form. I just know my highest degree tells me I should have 4 solutions. Okay, we're going to use this for the next section. Okay. Now this next section is Descartes' rules of signs. This is where you find the possible number of positive, negative, and imaginary zeros for a given function. So I'm not going to tell you, hey, you're using Descartes' rule of signs. I'm just going to tell you determine the possible number. You're not telling me what the solutions are. You're just telling me the possibilities of the combinations. Okay? So we are not going to substitute zeros for missing terms. Okay, we usually do. We're not here. You're going to count the number of sign changes. Okay, then you're going to count down by 2. So if I have 4 sign changes, I'm going to have 4, then I'm going to go down to 2, then I'm going to go down to 0. Okay, that's the possible number of positive real zeros. Okay, once you do that, you're going to find f of negative x. Okay, your original functions are always f of positive x, so that's your positive real zeros. Then we're going to have to find f of negative x to find your negative real zeros. Okay? Same thing. You're going to find the number of sign changes once you figure out what f of negative x is, and then you're going to count down by 2's. Once you do that, you're going to make a table with 4 columns. The 4 columns come from the fact that you are doing your positive, your negative, your imaginary, and your total zeros. Okay? I'm obviously going to make it neater than that. But you will always have 4 columns. The number of rows are determined by multiplying the number of positive choices by the number of negative choices. Okay? So, if I'm just starting with this function, I'm going to look. I'm starting with a positive and I go negative. So there's 1 sign change. Then I go from negative to positive. There's a second sign change. Then back to negative. That's a third sign change. And then I don't change again. Okay? You do not have to number that. You can do that in your head. I'm just showing you where the sign changes are. So for my positive zeros, I had 3 sign changes. I count down by 2, right? So 3 or 1. I could have 3 positive zeros or I could have 1 positive zero. Okay? So that altogether, how many choices is that? 2 choices. Okay? Now I'm going to find f of negative x. That means everywhere there is an x, we're replacing it with negative x.
So you switch everything except for the negative 8.
Mm-hmm. So all of those x's turn into a negative x. Then we have to simplify it. So think about...
I just started to do you actually have to write that?
Well, that's... So I want you to see this for you to understand the pattern of it. If I have any negative number raised to an even power, that's always going to be positive. Negative 2 squared is still a positive, okay? If I have a negative number raised to an odd power, that's going to be negative, okay? I'm showing you this. I always have to show you the background first before I can just tell you to shortcut it, okay? So I'm going to work this one out fully, but on the next example, we can just use this concept for your f of negative x, okay? So if I have negative x to the 6th, that's going to stay positive because I have a negative raised to an even exponent. So that stays positive x to the 6th. Now, if I take negative x, I raise it to a 5th power, that's odd, it's going to be negative. But I have to take into consideration the negative 2 in front, right? So I have a negative times a negative at this point, yes? That's going to turn it into a positive 2x to the 5th. Then I'm going to move on. Negative x raised to an even 4 just stays positive x to the 4th. Positive times positive, it's just going to stay positive 3x to the 4th. Then I have negative x to the 3rd. That's an odd power, so it stays negative. So here I am, I have a negative times a negative, so that's going to turn into a positive 10x to the 3rd. Then I have negative x squared. That's a positive x squared times a negative, it stays negative 6x squared. Negative 8 times negative x is a positive 8x minus 8. So I show you all of that to tell you the odd degrees are going to change signs. The even degrees stay. Okay? So the coefficients of the odd degrees are going to change signs. Now, we count the sign changes. I have a positive to a positive to a positive to a positive. Now, from 10x cubed to the negative 6x squared, that's my first sign change. Then I have another sign change. Then I have another one. So for my negative possible zeros, I have 3, count down by 2, or 1. Okay? So altogether, that's 2 choices also. So I have to see, you tell me how many positive zeros. I have to see at least this. You don't have to show me this part, but I do have to at least see this. Okay? And then I want to see the negative zeros. Okay? Now we're going to figure out how many rows do I need. Well, remember that your rows are the number of positive choices times the number of negative choices. So I have 2 times 2, so the number of rows I have are 4. This is kind of like probability. Okay? So I'm going to set up my table. Try to make it as neatly as possible. If you need a ruler, then use a ruler. Okay? I'm going to have 4 columns no matter what. And I need 4 rows on top of the row that already has my total. Not my total, my title. Okay? So you always have to have your title. That tells you what the column is even about. So you're always going to have the plus, negative, imaginary total. Then you're going to have 4 rows below that. Y'all follow me? Okay. Now to fill it out. I always start with my positives. I could have 3 positives and 3 negatives. Or I could have 3 positives and 1 negative. So you're pairing those together. Y'all see what I did? Then I'm going to look at I could have 1 positive and 3 negatives, or I could have 1 positive with 1 negative.
So is the wait, I'm going to make a guess here. Can I do that?
Sure.
So the imaginary would be whatever is left, because there is 6 answers total.
Yeah, so
say
you're,
on the bottom one there would have to be 4 imaginary.
yes. So you're going to have to look at your degree here. Your degree is going to tell you what the total is. I have a degree of 6, so every single option better have 6 total solutions. So if I have 3 positive and 3 negative, well, there's my 6. I don't have any imaginary. Okay? If I have 3 positive and 1 negative, there's 4. I need 2 imaginary. 1 positive, 3 negative, there's 4. I need 2 imaginary. 1 positive, 1 negative, I need 4 imaginary. So what you're doing is you're adding your positive, negative, imaginary to equal the 6. Y'all good with that? Y'all have any questions? Okay. So last example. If I'm looking at my original function, I have a sign change, then another one, and then at the very end I have 1. So I've got 4 sign changes. So for my positive zeros, I could have 4 or 2 or 0. Yeah? Okay. Now I need to find my f of negative x. So I told y'all the odd exponents, those coefficients, change signs. So it's going to turn into a negative x to the 5th. My evens do not change, so minus 3x to the 4th. That 5x to the 3rd changes to a negative 5x to the 3rd. Negative x squared. Negative 6x changes to a positive 6x, then plus 4. Y'all follow me on that? Okay. So I don't have a sign change until negative x squared going to positive 6x. So for my negative zeros, I have exactly 1. So for my possible positive zeros, I have 3 choices. And for my negatives, I only have 1 choice. So how many rows am I going to have? 3. Because you would do 3 times 1, which is going to give you 3. So I'm going to make my table. I'm going to have my header already there. How many total solutions should I have? So I could have 4 positive and 1 negative. I could have 2 positive and 1 negative. Or I could have 0 positive and 1 negative. Then I fill in my imaginary. Well, if I have 4 positive, 1 negative, I don't need imaginaries. If I have 2 positive, 1 negative, I need 2 imaginaries. Then I'm going to need how many? 4. Are good with that?
Yes.
Any questions?